Hi, Prof. This is our presentation on our mini project. I am Asher, and my group mates are Dennis and Sheng. This is the content page of our presentation. So the background of our topic. Crowdfunding is a very accessible way for entrepreneurs to gain funding for their businesses. Yet a lot of crowdfunding campaigns fail. And because they fail, these businesses lose the ability to expand themselves on a larger scale. Our project's objective is to give businesses a better idea on which variables they can tweak to ascertain the success of their crowdfunding campaigns. Our problem statement is to predict the success of crowdfunding campaigns. Now I'll pass the time to Dennis.
So for our data set, we found a data set of all the past Indiegogo crowdfunding campaigns that were held between 2011 to 2020, which is around 22,000 campaigns. For our data cleaning, we first checked for missing values in the data set. Throughout the entire data set, only the tagline column had missing values, and it was only 12. Given that our total number of campaigns is over 20,000, removing the 12 would result in a very small and insignificant loss of data, thus we chose to remove it. Next, we realized that there was similar data in the data set. For the following category variables, currency, category, and month launch, we saw that our dataset also included in a one-hot format. So, since there is redundancy in the data, we chose to remove the one-hot format data from the main dataset. Lastly, we chose to remove the project ID, T period, and URL column in the dataset as well. These variables are used to provide a unique identifier for each of the campaigns in the dataset. This will not provide any meaningful information and is very unlikely to have a relationship with whether a campaign is successful. Thus, we remove them as well. So for our EDA component, we'll be looking at each individual variable and checking if these variables have a relationship with the success rate of the campaigns. We do so such that when we feed these variables into a machine learning model, we don't feed any variables that does not provide any meaningful value to determine if a campaign is successful. So we have 5 variables to check, which is country, category, month launch, which are category variables. Title and tagline are considered as category text features or string variables. We use chi-square and Kramer V to determine if the category variables have a relationship with success rate and point biseral correlation for the two string variables. So what is chi-square and Kramer V? Chi-square test is basically a hypothesis test, and Kramer V is a measure association, and both of these determines whether two category variables have a relationship. So for chi-square test, the 9 hypotheses will be variable A and variable B have no relationship, while alternate hypothesis is the two variables have a relationship. For Kramer V, getting a 0 to 0.2 coefficient implies a weak relationship, 0.2 to 0.6 implies a moderate relationship, and 0.6 to 1 implies a strong relationship. Now we'll look at the category variable relationship with success rate through these two tests. So first, we have country. The null hypothesis for this would be country and success rate have no significant relationship, and alternate hypothesis is that they have a relationship. As you can see from test, the p-value of chi-square test come at this number, which is basically 0. So you can confidently reject the null hypothesis and say that yes, country and success rate have a relationship, and looking at Kramer V coefficient is a very weak relationship. Similarly, for the next variable, we'll come to a conclusion that category and success rate have a really significant relationship and is a moderate relationship. Lastly, for what is the month launch of the campaign, you can see that the month launch and the success rate have a significant relationship, but it is a weak relationship. Before finding out the relationship between string variables and success rate, we have to first do some sentiment analysis on title and tagline first. Sentiment analysis, also known as opinion mining, is a subfield of natural language processing that involves using computation techniques to automatically identify and extract subjective information from text. Specifically, it's the process of determining the sentiment or emotional tone of a piece of text. To do sentiment analysis, we'll be using the DistillBird model, which is a smaller and faster pre-trained language model that uses a variant of the transfer architecture and trained using knowledge distillation. So to show an example, if a text I shown in the slide, send me to Haji, I'm needed there. What we do is input this text into the DistillBird model and output back two things, the positive and negative sentiment of the text. So in this case, the statement has a 5.96% negative sentiment and 94.04 positive sentiment. We can do this for the entire dataset title and tagline and use the positive sentiment score as the variable to determine if it has a relationship with success rate. So we'll make use of the point biseral correlation, which is a type correlation coefficient that measures the strength and direction of the association between a binary variable, such as success rate, and a continuous variable, such as sentiment score. And as you can see, we can conclude that title and tagline have a relationship with success. Now, after we determine the variables that have a relationship with success rate, we will feed these variables into a bunch of classification models and find which models are the most accurate and best at predicting whether a crowdfunding campaign is successful. So I've used the following models: decision tree, random forest, support vector, k-neighbors, and lastly XGBoost. I'll be explaining only the support vector model and XGBoost model due to time constraint. So for the support vector classifier model, it's a type of machine learning algorithm that belongs to the family of supervised learning algorithms. It's commonly used for a binary classification problem, where the goal is to predict which of the two classes a given data point belongs to. The main idea behind SVC is to find the hyperplane that separate the two classes with the largest margin. The margin is defined as the distance between the hyperplane and the closest data points for each class, and the hyperplane that maximizes this distance is considered the best separator. XGBoost classifier model, which stands for Extreme Gradient Boosting, is a scalable distributed gradient boosted decision tree machine learning library. It provides parallel tree boosting as the leading machine learning library for regression, classification, and ranking problems. The idea of boosting or improving a single weak model by combining it with a number of other weak models in order to generate a collectively strong model. So as to how we judge whether our model is best, we do not use accuracy as a metric to judge. Because our dataset is not balanced, with significantly more negative samples, accuracy will not be a good measure. Instead, here we have three other measures, which are precision, recall, and FI score. And we choose to maximize precision because we want our prediction of true positive to be as correct as possible. This means that when our model predicts that the campaign will be successful, it's very likely that it will not give a wrong prediction. We choose precision because naturally a campaign will want to succeed, and it will adjust itself when the model predicts unsuccessful. So getting the most accurate successful prediction is needed. So here are the scores for each of our model. For the decision tree, here are the results. The random forest tree model with the results. Next, the support vector classifier model with the results. Key neighbors model classifier model with the results. And lastly, XGBoost model with the results. So the top two best model with the highest precision score will be XGBoost and SVC. So now, we'll include the sentiment score that we previously got and insert them into the model and see how this affects the performance of our model. As we can see, the variables being added have little effect on improving our model. In fact, for both cases, the precision of our model dropped. So we can choose to follow sentiment analysis moving forward. So next, to check the reliability of our model and making sure that it does not overfit, we'll be doing stratified k-fold cross validation. What this does basically is split our dataset evenly into k number of different parts, with each part having the same proportion as the main dataset and checking the performance of each part. So from the results obtained, we can see that actually for both SVC and XGBoost, the performance improved. Thus, this implies that the model underfit. Thus, we can actually be more confident of our model than what it implies. Lastly, we'll be doing hyperparameter tuning to enhance the performance of the two classification model. Hyperparameter tuning refers to the process of selecting the optimal hyperparameters for a machine learning model to achieve the best performance on a given dataset. Hyperparameters are parameters of a machine learning model that are set before the model is trained on the data and cannot be learned from the data during the training process. So after we conduct hyperparameter tuning on the SVC model, those are the best parameters for our model based on our dataset. And using these parameters, the new performance of our model is with a precision score of 0.821, which is a drastic improvement from 0.693. For XGBoost, the best parameters are as shown. And with these new parameters, the performance of XGBoost model improved the precision score of 0.829, up from 0.690. So what are the results and insights gotten after this process? After tuning the hyperparameter, we do see a drastic improvement on our precision score. The new algorithm has hugely decreased the false positive but comes at the expense of increasing the false negative slightly. This is a trade-off between precision and recall. This means that in our model, when the learning algorithm is unsure, you'll be more likely to output as 0 than to take the risk to output as 1. But this suggests that when the model were to predict that a campaign is successful, chances are the campaign is very likely to be successful at a confidence level of 82%. Overall, we see that there's no significant difference between the two models even after hyperparameter tuning, since the precision score only differs by 0.008, which is so little. Hence, we cannot come to a conclusion which model is better. But just by looking at the numbers, XGBoost classifier model is the one to go with. So now, with this classifier model, we are able to predict with an 83% level of confidence whether campaigns will be successful. So for our area for improvement, as previously mentioned, the sentiment analysis did not provide any meaningful improvement to the performance of the classification model. This could be because relying solely on sentiment score can be insufficient because it oversimplifies the complexity of human emotions and language. To improve the sentiment analysis, it's necessary to consider the context in which the text was written. Thus, we could instead incorporate entity recognition and semantic analysis. Another thing that we can improve on is getting a more balanced dataset. Currently, our dataset have significantly more samples that show campaigns being unsuccessful, which will lead to our model favoring one class for another, thus a bias estimation. What we can do instead is either to oversample the minority class or undersample the majority class. That's the end of our presentation. Hope you gain new insights on crowdfunding. Thank you.